All right, January the 19th through the 22nd. We're going to be looking at lesson 27. All right. So our goal for today is to take everything that we've learned in the last 4 lessons and to apply it in proofs. All right, so let's go ahead and get started with this. So we are given AB is equal to AC, and we are given RB is equal to RC. So it wants us to prove that SB is equal to SC. Alright, so let's go ahead and list our given information. So we're given AB is equal to AC, and we're given RB is equal to RC. Why? That is a given. Alright, I'm going to go ahead and mark it. So AB is equal to AC, and RB is equal to RC. Alright. So basically, let's look at this. We're going to look at proving triangles congruent. Even though my proof does not ask for me to prove a triangle congruent, we're at some point in time going to have to prove triangles congruent. Let's go ahead and look at this. Guys, we're already very close to proving this triangle congruent to this triangle. I can do that with one more step. If you look at this, AR is a part of both triangles, so I can say that AR is equal to AR by the reflexive property. Alright. Now, if I look at this, that means that I have proven 2 triangles congruent already. I have been able to prove that triangle ABR is congruent to triangle ACR. How have I proven that? Well, look, I've proven it by side, side, side. Alright. So since I've proven triangles congruent, I now know that every corresponding part is equal. So let's figure out why I needed to do this. I want to prove that SB is equal to SC. Probably at some point in time, I'm either going to have to prove these 2 small triangles congruent or these whole big triangles congruent. Alright, so since I've proven these two small triangles congruent, like I said, I now know that every corresponding part is congruent. So let's look at my next part. The next thing I want to do is I'm going to prove that I have equal angles. So I'm going to say the measure of angle ARC is equal to the measure of angle ARB, and that is by that CPCTC. Corresponding parts of congruent triangles are congruent. Alright? They're equal in measure. So now I've proven that this angle is equal to this angle. Alright? Alright, so with that being said, let's think about this for a second. The reason I did this is because what do I know about this angle, and then this angle and this angle? Well, if I look at that, they form a linear pair, which means that if this angle is equal to this angle, then these 2 have to be equal. So I'm moving one step closer to proving triangles congruent. Alright, so I can now say that the measure of angle ARB plus the measure of angle BRS equals 180 degrees. And I can say the measure of angle ARC plus the measure of angle CRS equals 180 degrees. why do these two form, or why do these two equal 180 degrees? Because linear pairs form supplementary angles. Alright. So since I know that they are supplementary angles and they form a linear pair, we just talked about this. So if this angle equals 150, then this one has to be 30. But if this one's 150, that means this one's 150, which means this one also has to be 30. So the measure of angle SRC is equal to the measure of angle SRB. SRC and SRB are equal because angles supplementary to either the same angle or the congruent angles are equal in measure. Okay, so I now know that these two angles are equal. Alright? Alright, so now that I've done that, think about this, guys. I'm back to proving these two triangles congruent. Guys, what do I know about SR and SR? SR is equal to SR because of the reflexive property. Alright. Now, look, have I been able to prove these two triangles congruent? I have. So triangle SRB is equal to triangle, or I'm sorry, it's congruent to triangle SRC. How do I know that? By side angle side. And now that I've proven those two small triangles congruent, SB is equal to SC because of CPCTC. Okay? Corresponding parts of congruent triangles are equal in measure. Alright, let's look at number 2. I have square ABCS and square EFGS, so these are two squares. And I have RAB is a line and REF is a line. Alright, so these are lines, these are squares. That's what it tells me. Alright, so let's go ahead, we're going to split this up. And we're going to do square ABCS is congruent to square EFGS. That is given. So since we know that they're squares, alright, then what do I know? Well, let's go back and see what they want us to prove. They want us to prove that triangle ASR, this triangle here, is congruent to ESR. So they want us to prove these two triangles congruent. So since we know these two squares are congruent, then I know that AS is equal to ES. And this one, corresponding sides, of congruent squares are equal. Okay, so that kind of goes along with the CPCTC, only now we're dealing with squares. Alright, so I've proven that these two sides are equal. Alright? Alright. We're working on trying to prove these two triangles congruent. What else do I know? Well, guys, SR is part of both triangles, so SR is equal to SR by reflexive property. Alright, so we are very close to proving our triangles congruent, but we do have a few other steps that we need to look at. Now we're going to go back to where it talks about being squares. What do we know about squares? We know that that forms right angles. So what I want to do is I want to look at this angle here because I think this is going to help us. So because it is a square, I know that angle BAS and angle FES are right angles. Alright, and that's just the definition of a square. Alright, definition of a square. Alright. Since I know that this is a right angle, what do I know about this and this? Well, they form linear pairs. Alright. So angle BAS and angle SAR form a linear pair. And I'm going to go ahead and I'm going to combine this into one step. Angle FES and angle SER form a linear pair. Alright? And that's simply the definition of a linear pair. If I know they form a linear pair, then if this is a 90-degree angle, what does this have to be? It also has to be a right angle. So angle SAR and angle SER are right angles. And we can say two angles that are supplementary and congruent. Each measure 90 degrees and are therefore right angles. Alright, so since we know that those are right angles, then what do I know about these two triangles? We know that they are right triangles. So triangle ASR and triangle ESR are right triangles. And that's simply the definition of a right triangle. Okay, and what's the point of us proving the right triangles? Well, look at this, guys. If you remember the HL theorem, if I have a hypotenuse of each triangle and a leg of each triangle that are congruent, then I can prove them congruent. So triangle ASR is congruent to triangle ESR by hypotenuse leg. Okay? So I have proven them right triangles, so I have proven them to be congruent. Alright, number 3. notice our theorem, or our proofs are getting a little bit longer. Alright, so JK is equal to JL, JX is equal to JY. I want you to prove that KX is equal to LY. Alright, so let's go ahead and list our given. Let's split it up first. So JK is equal to JL. We're going to say that's given. JK, JL. Alright. Since, let's look at this as a whole triangle. And since I'm dealing with two sides equal, I know it's what kind of angle. What kind of triangle. I know it is an isosceles triangle. And since I know this is an isosceles triangle, then I know that I have congruent base angles. Alright, so the measure of angle JXY is equal to the measure of angle JYX. So I forgot to put my rest of my given statement, sorry. JX is equal to JY. I was forgetting something there. Okay, so I've got JXY and JYX base angles of an isosceles triangle. Are equal in measure. Okay? Alright. So now let's think about this for a second. Where do we go from there? Well, let's look at this. JXK and JXY would equal what? They would equal a linear pair. So they would equal 180 degrees because they're a linear pair. So would JYX and JYL. Alright, so we're going to go ahead and we're going to list that as our next. So the measure of angle JXK plus the measure of angle JXY equals 180 degrees. And the measure of angle JYL plus the measure of angle JYX is equal to 180 degrees. Alright? And the reason being is linear pairs form supplementary angles. So since we know that these are linear pairs, let's think about this. Okay, what do I know? Well, I know that this must be equal to this. Alright, I know that they have to be equal because of substitution property. So the measure of angle JXK plus the measure of angle JXY must be equal to the measure of angle JYL plus the measure of angle JYX. Alright, so substitution. They both equal 180. Remember, if A equals B and B equals C, then A is equal to C. So if this equals 180 and this equals 180, then I know that they are equal together, or they are the same. Okay, now let's think about this for a second. So if I know that this is equal to this, so if this is, say this is 50, and this is 50, what does this have to be? This has to be 130, that has to be 130. So now I can say that these two angles are equal. Alright? So the measure of angle JXK is equal to the measure of angle JYL. Angle supplementary to either the same angle or congruent angles. In this case, we're looking at congruent angles are equal. Okay, so now I've proven that this angle is congruent to that angle. Alright. Now, what else do I know? Well, let's go back to JK and JL being equal. So now look at this. I know that I have base angles of an isosceles triangle again. So the measure of angle K is equal to the measure of angle L, because base angles of an isosceles triangle. Okay. Alright, so I've proven these two angles congruent. Alright, so with that being said, let's look at this. I've now proven these two small triangles congruent. Because remember, my goal is to prove that KX is equal to LY. So I've proven these small triangles congruent by angle, angle, side. And since I've proven them congruent, I can now say KX is equal to LY by corresponding sides of congruent triangles are equal. Corresponding sides of congruent triangles are equal. Okay, and you can, we've been normally doing CP, CTC. We're going to do corresponding sides of congruent triangles are equal. Okay. All right. Number 4. All right, number 4. I'm given that AD is perpendicular to DR. I'm given that AB is perpendicular to BR. I'm given that AD is congruent to AB. And they want us to prove that angle DCR is equal to angle BCR. So they want us to prove these two angles equal. Okay? So let's go ahead. We're going to look at AD is perpendicular to DR, and AB is perpendicular to BR. That is given information. Since we talk about perpendicular angles, alright, what do we know about that? That means that we have right angles. So that means that I have right triangles. Alright, so we're going to skip listing a bunch of steps that we don't really need. You know, we have now to the point that we know what a right angle means. Alright, so I know that ADR, triangle ADR, and triangle ABR are right triangles. And I know that because the definition of right triangle. It requires one right angle. And guess what? I have a right angle right here and a right angle right there. Okay? Alright, my next step, I'm given that AD is congruent to AB. That is given. So AD is congruent to AB. Okay. Look, I'm close to proving triangles congruent here. All right. Since I'm dealing with a right triangle, I've got a side or a leg. All right. I need to prove the hypotenuse. Guys, AR is equal to AR because of the reflexive property. Alright, so there we have it. I have now been able to prove that these two triangles are congruent. A hypotenuse leg. Okay, now, why is that important? Well, let's think about this for just a second. They want us to prove that DCR, that these two angles are congruent. Alright? So, what do I know about, I gotta figure out what else, where I can go from here to help me get to that point. Well, I'm going to talk about ARD and ARB. Alright, I know those two angles are congruent. I know they are congruent because corresponding parts of congruent triangles are congruent. So CPCTC. Alright, so I know that that angle is congruent to that angle. Alright, now let's think about this for a second. What do I know? Well, I'm going to kind of look at it like this for a second. What do I know about these two parts? They form linear pairs. Alright, so they're equal to 180 degrees. So the measure of angle ARD plus the measure of angle CRD equals 180 degrees. And I'm going to go ahead and put that second step here. Measure of angle BR A plus the measure of angle BRC, I want to make sure I get the right letters here, equal 180 degrees. Linear pairs form supplementary angles. Okay. Alright, so since I know that that's the truth, then what do I know about these? I can go back up here and think about what did I do? Well, now I know that the measure of angle ARD plus the measure of angle CRD is equal to the measure of angle BRA plus the measure of angle BRC. Why do I know that? Because angles supplementary to either the same angle or congruent angles are equal in measure. Alright, so now I can say, you know what, I skipped. This should be transitive property. Sorry, I got ahead of myself. This is my statement for my next one. So looking at this, because of this, I can now say that the measure of angle DRC is equal to the measure of angle BRC because they're congruent to the same angle. Okay, so that was number 9. Alright, number 10. Alright, my next step. So now I can say this is congruent. Alright. What do I know about RC? I wrote over top of it. I know RC is equal to RC because of reflexive property. Okay. What do I know about DR and BR? I know DR and BR are equal because they are corresponding parts of congruent triangles. With that being said, I can prove these two triangles congruent. Alright, they are congruent. I'm running out of room here. Make sure you can see what I'm writing. Alright, so triangle DRC is congruent to triangle BRC by side angle side. And since they are congruent, then I know that angle DCR is congruent to angle BCR. Corresponding parts of congruent triangles are congruent. Okay? Alright, I would like for you to do number 5 and number 6. I want you to work on those and then turn them in and I will look at them. Alright? You are just putting together everything that we've done in the last 4 lessons. Alright guys, have a great week and I will see you next week.